Hi, guys, and welcome to your seventh week of Teleschool. And today we're going to go in depth in magnetism. Right? So, magnetism is a force of attraction or repulsion caused by the movement of charged particles. Okay, so note it is not a charge, and then it is caused by the movement of charge. So, it's not a charge, it's just the result of the movement of said charge. Magnetic poles. All right, you guys may recall using a compass. All right, so from the north and the south and the east and the west on your maps. All right, so magnetic poles are regions on a magnet which produce magnetic forces. The poles of a suspended magnet will align themselves to the poles of the Earth. So, thinking of a compass. So, the fundamental rule, like poles repel, opposite poles attract. All right. So, you're going to have your different poles. So, your opposite poles are going to be attracted, and your like poles are going to be repelled, just like we were talking about the electrons. So the electrons are repulsed by other electrons as protons are attracted to electrons, and that's all based on the charge. Magnetic poles behave similarly to electric charges except for a few cases. So magnetic poles cannot be isolated. So you can't just cut a magnet in half like you have on this big one right here, because then you're just going to end up, having the charges split, where now that bottom half is going to be that reinforced north and the other side being south, and vice versa. You're going to have the top half being south and the other half being north. All right. So you can't just chop that magnet in half and just have this bottom half be north and this top half be south. All right. I hope that makes sense. Magnetic fields. So, a magnetic field is the space around a magnet in which magnetic force is exerted. The shape of the magnetic field is revealed by the magnetic field lines. And typically, you don't see those magnetic field lines unless you have some form of iron or some other things that have, a charge that will want to go from one side to the other and directed away from north poles and towards south poles. And the strength of a magnetic field, or strengths of magnetic fields, are measured in units called Tesla, or capital T. So here are your magnetic field lines, and you can see that our north is going to our south, and then on the other side, our north is going to our south. And because these are opposite sides, they will be attracted in the middle. If you had two, let's say two souths together, all right, they're not going to be attracted. Actually, they're going to be repulsed because they don't want to be close to each other. Opposites attract. And this is the same sort of visual that we're talking about before. So we have things from the north, and they're all traveling in direction to the south. So now we're going to talk about Earth's magnetic field, and this is probably the one that you guys have heard about most frequently. So the currents in the molten part of the Earth beneath the crust create the Earth's magnetic field, and here is where the core is. So there are a bunch of different materials floating inside of that core that make up that inner molten portion. All right, it can be iron, and then some other metallic elements that form that electric charge. So the Earth's magnetic field is not stable. The magnetic pole and the geographic pole are offset, and we're going to look at that in just another slide. All right, so the magnetic poles are located, so the north is in the Hudson Bay region of northern Canada, so up here. And then south, just a little bit south from Australia. And what they mean is that this side, all right, this side is going to be your south, this side is going to be your north, okay? But whenever we're talking about magnetic and geographic, what we mean is that the geomagnetic pole, all right? So although this is north, the north magnetic pole, you're going to be seeing that it's going to resemble the south side, all right, of the magnetic pole, and vice versa. The south geographic pole is going to represent the north. So you're still going to be going from north to south, all right? But when you're thinking about this, or if you weren't aware of it, you would be thinking that the pole would be going this way because this, north geographic and north geomagnetic, you'd be thinking that they would be, it would be north or north south, but that's not correct. So magnetic declination, okay, is the difference between geographic and magnetic poles. So this is a little bit confusing, but just think about the Earth, when you're talking about those geomagnetic poles, just think about them opposites. So instead of north being the North Pole, all right, it is actually representing the south side of that pole. It's very confusing. So the magnetic field of the Earth reverses on an irregular cycle. Its strength has decreased by 5% over the last 100 years, and that indicates a reversal in the possibly in the next 200 years. And recall, electric current is the movement of electric charges. Current produces a magnetic field. When current is carried through a conductor, the magnetic field produces a pattern of um, uh, concentric circles. I apologize. Concentric circles. And you can see that once more with this picture here. They're making like the little, it's kind of like they're making crop circles or something. Perhaps that is, it's not aliens, it's magnets. So the electric current, this concept is known as Oersted's principle. If the current switches direction, the compass needles will turn 180 degrees. So remember that you have a circle. A whole circle is 360 degrees. Like the whole way around a circle is 360 degrees. But when you just go from here to here, that is 180 degrees. So basically, just doing half a circle. So we see the electric current being represented here, and the magnetic compasses are going to go in this direction, this counterclockwise direction. All right, but if the current switches direction, the compass needles will end up switching from counterclockwise to clockwise. And electromagnets, a temporary magnet made by running an electrical current through a coil of wire wrapped around an iron core. And this coil of the wire is called a solenoid. Electromagnets behave like normal magnets when activated, north and south poles, field shape, etc. So I'm sure that you guys have done something similar in elementary school where you created your own temporary magnets. where you were able to make your magnet actually work, for a short amount of time. And then when it's not connected to an electric power source, all right, or an electric current, then you would not have that same pull on that magnet, i.e., it wouldn't be a magnet anymore. So, electromagnet application. The an alarm bell uses an electromagnet with changing magnetic field to move the plunger. So when you hear, the bell at school, when we were inside the school building, that was a form of electromagnet. Also, one you may be more familiar with is an electromagnet is used at the junkyard. So if you have something really heavy like a car, you can have that electricity running through, and this part right here, it essentially becomes an electromagnet and is able to pick up that car. And what would end up happening is that if you decided to shut off the electric current that's going into this machine right here, then the car would drop because there would be no more magnetic pull on this. So if you wanted to make your electromagnet stronger, you could run more current through the wire coil. So you would probably need a lot more energy, about a lot bigger of an energy source to provide that electric current. You can increase the size of your iron core, so the bit that's going to make it magnetic, or you'd add more coils of wire, which would, increase that as well. And luckily, you guys, we have an example from Dr. Taylor where he shows you on the next slide how to make your own electromagnet. So you guys should check it out. I don't know if you'll be able to do this at home to this extent, but maybe you can figure out something of your own. And make sure you guys complete the questions, and I will see you guys in the next video.